Good morning. My name is Ming, and I am a fourth-year statistics PhD student at the University of California, Santa Barbara. I am pleased to present to you my research on state-space assessment on the impact of COVID-19 on housing security for young adults in the United States. First, we would start with a quick introduction on the research question, the data we analyzed, and the challenges and significance of the research. Second, I want to present the dynamic modeling framework, which is the main method for this project. Third, I want to share with you the applications, which includes two scenarios, one for individual households and the other for the states. And lastly, I want to end up with a quick discussion of the findings from this study. The motivation for this project is the impact of COVID-19 on housing situation for young adults. The economic fallout of the COVID-19 pandemic disproportionately impacts groups that are financially vulnerable. This is also showing disparities in education, employment, housing, and healthcare. While millions have been struggling with housing expenditures, there is a nationwide housing crisis going on, and in particular, young adults in the US are faced with heavier existing loans, lower income from wages, less job opportunities, and a lack of savings. Policies targeting the housing hardships have been implemented, including the eviction moratorium. Detailed data analysis is crucial to monitoring the situation and evaluating the execution and effectiveness of these policies. Our goal in this project is to combine comprehensive sources to analyze factors influencing the current housing crisis and produce data products to help families and communities navigate through the current challenges. We would like to extract data both at the micro level for individual households and the macro level for the states, while incorporating different perspectives. And we want to perform predictions that can utilize a continuous flow of nearly real-time data, which is also known as online predictions. This takes consideration of the development of the pandemic and is highly useful for making informed decisions. And lastly, we want to understand the dynamic interconnections between different variables to identify risk factors and support good decisions in real time. For this study, we are interested in considering data covering the following three aspects. In particular, we want to cover both direct and indirect perspectives. So for example, broadband access is an indirect factor reflecting the remoteness of a particular household. Now, the core data set is the 2019 American Community Survey one-year estimates, and we include this to form a comparison with the current data during the pandemic. ACS is conducted by the Census Bureau and provides a solid background on the nation and the well-being of its people. Its annual estimates report on nearly every facet of our way of life and may be classified into four categories. The second data set is the Household Pulse Survey, which is also conducted by the Census Bureau and is dedicated to investigating how the pandemic is impacting households and the livelihoods of ordinary people across the country. This covers from April 2020 at the beginning of the pandemic to the present and supports an effective interactive data tool. In particular, it provides a detailed public use data file at the weekly and household levels, and the phase 1 data for HPS includes longitudinal samples, which are samples based on repeated measurements. We would also want to include COVID-19 case numbers from CDC and the mobility data from Apple, showing volume of directions requests to reflect transportation during the pandemic. Our main research question for this study is to address the concern for developing an efficient model at the household level and the state level to extract information from individual households, explore dynamic connections between longitudinal variables, identify factors for increased risk of a housing crisis, and perform online predictions. We would like to better understand the housing crisis due to COVID-19 among young adults of age 18 to 24 and inform timely decisions. The novelties of this study lies in the challenges we face, which comes from both processing the data and implementing our objectives. First, we want to conform different sources of data to the same spatial temporal scale. Then we need to model dynamic relationships under a computationally efficient framework to accommodate the large scale of data that we are working with from incorporating different sources. And we want to predict multi-step outcomes while being capable of incorporating updated data throughout the development of the pandemic. Therefore, we propose to adopt a joint modeling framework based on state space models for longitudinal analysis. State space models are based on Kalman filters, which were first developed in the 1960s. It consists of two equations, the first being this observation equation based on the observations yi at time tj, and the second is the state equation, which models the latent states alpha I, which we assume to be an underlying state affecting the observations. We also make three important assumptions about the state space models for our study. For the probability of housing crisis, we adopt a joint modeling framework based on the state space model and a regression model which covers the occurrence of a housing crisis at the individual household level. So we call rho I, we denote rho I as this occurrence following a Bernoulli distribution with probability pi I, and modeled with the logistic regression based on covariance xi. Furthermore, at the state level, we will consider the following model, which is essentially a binomial regression, using hi as the total number of households facing crisis in a given week, and si as the proportion of households experiencing a housing crisis. So si is hi divided by the number of households n. So this is also modeled with logit and covariance xi. Now, for our application, in the first scenario, we consider the beginning of the pandemic when little were collected, and it was critical to identify individual households experiencing or at risk of a housing crisis, so support can be provided, emergency financial reliefs, etc. We consider one longitudinal variable, which is the household money spent in the last week on food for 55 different households across the country and 3 surveyed weeks from May 6th to May 26th, 2020. The reason we are selecting household money for food is because more often than not, food sufficiency is affected in households facing housing crisis and vice versa. We select a total of 7 covariates, including gender, education from household pulse survey, and then from ACS 2019, we select percentages of broadband access of occupied households and health insurance, and then additionally COVID-19 cases from CDC and mobility data from Apple. In this first figure, we see the household money on food in the past week for 5 randomly selected households. And we see that after plotting the crisis faced by each household, if it exists, among these 5 households, 1 household has faced housing crisis for all 3 weeks that were surveyed. This is a strong indicator of the severity of the situation. And in the next couple of slides, we will illustrate the online prediction capabilities of the proposed dynamic modeling framework. We note that uncertainty increases due to forecasting further into the future. You see here in figure 2 is the filtering estimate of longitudinal trajectories of household money on food from a random household. And when we only have 2 weeks available, the forecast is an upward trend. But once the third week's worth of data becomes available and we consider it in our prediction model, the food expenditure is now a slightly downward trend. So the prediction is successively considering this updated data. So this is the greatest benefit of online prediction, that it incorporates data as they come in. Furthermore, we can estimate the probability of housing prices in the next 2 weeks for a specific household. And you see for 2 weeks, this is a downward trend going from about 0.043 to 0.041. And when the third week is considered, this downward trend is continued. So this is definitely good news for this specific household. So essentially, for the first application, we are using our proposed method to help navigate the probability of housing crisis for specific households when there is a limited amount of data at the early stage of the pandemic. For the second scenario, we are considering the situation where the pandemic has been ongoing for several months, where sufficient data were collected, and the goal is to make informed decisions at the state level regarding housing prices. Here, we consider 2 longitudinal variables: the average of household money in the last week on food, and the proportion of employed people among all surveyed in each state from the household pulse survey. We have now 50 states plus Washington, D.C., and 12 surveyed weeks from April 23rd to July 21st. We again select a total of 7 covariates, much like the first scenario, except many are now percentages and proportions. In figure 4, we show the employment status for 5 randomly selected states, and you see that based on HPS, they have seen quite a bit of variation in the span of 12 weeks. As for the average of household money on food, for these 5 states, we see in particular for Texas, there is a significant hike around week 5. So this might be some concern. In the following slides, we will demonstrate a more effective and accurate online prediction due to a richer collection of longitudinal data over time. You see in figure 6, filtering estimates for longitudinal trajectories of proportion of employed for the state of California. If we start from week 8, so we only have 8 observed weeks worth of data, then we predict a slightly upward trend with confidence bounds on both sides. And then week 9 becomes available, and it's almost a perfect fit for our prediction. And then we update our prediction, now covering up to week 15 instead of 14. And it continues for week 10, 11, and the last week 12. All 9, 10, 11, and 12 falls close by our prediction and within the confidence interval. This can also be done for trajectories of average household money for food. And you see this is another good fit, except the food expenditure is consistently going up. We know that food industry was impacted by the quarantine, and this is showing that increased food expenditure may cause extra hardships for households in California. Lastly, the estimated proportion for housing crisis 6 weeks into the future for California is shown here, and we see that there is quite a bit of variation, showing the necessity of this accurate prediction to help guide policy in California. So our findings supplement housing analysis from the HPS interactive data tool. And based on the proposed method, we are currently developing a dynamic modeling data tool as encouraged by the Opportunity Project in the Product Development Toolkit. We hope to make this available to the general public in the coming months. The current joint modeling framework may be extended to include more variables to better utilize the wealth of information available from ACS and HPS, and both are extremely valuable and effective resources for comprehensive analysis of COVID-19 impact on the United States. Finally, we would like to conduct further research incorporating these two resources and additional data tools from TOP in the following months on a more challenging data scale. So thank you for attending my talk. I want to express my sincere gratitude for having this opportunity to present here today and for the wonderful data sets provided by Census Bureau and the Opportunity Project. I look forward to discussing how to use these data to analyze COVID-19 impact with you in the future. Thank you.